Welcome back to Quick Statics Answers. Today's question is, determine the forces in each member. First, we'll draw free body diagrams of the forces at joints A, B, C, D, E, F, and G, assuming they are all tension forces. We will call tension forces positive. Forces along their members are drawn in pink, and reaction forces are drawn in green. At point E, there is a roller, so there is a reaction force perpendicular to the surface. And at point A, there is a pin, so we will have both X and Y component forces. Next, we'll solve for the force EY by taking the moment around point A. Looking only at P1, P2, and EY, we get the following equation. The result is that EY equals 12.5 kilonewtons. Next, we'll take the sum of vertical forces, which results in the following equation. We just solved for the value of EY. So after substituting this value into the equation, we can isolate for the force AY, which results in 17.5 kilonewtons. Next, we'll evaluate the horizontal forces, and because AX is the only horizontal force, it must equal 0 for the structure to be in equilibrium. To evaluate the forces at joint A, we must first determine the angle between members. This is done by taking the tangent of the ratio of the given side lengths, and results in an angle of 53.13 degrees. Knowing this angle, we can now solve for the forces at joint A. Taking the sum of vertical forces gives that FAB is equal to 21.9 kilonewtons in compression. Since this is a compression force, we must flip its direction in the free body diagram. Taking the sum of horizontal forces gives that FAG is equal to 13.1 kilonewtons in tension. We'll apply the same process at joint E. Taking the sum of vertical forces gives that FED is equal to 15.6 kilonewtons in compression. Since it's in compression, we must flip the force on the free body diagram. Taking the sum of horizontal forces gives that FEF is equal to 9.36 kilonewtons in tension. Next, we'll take a look at joint B. Since we previously determined that FAB is a compression force, we need to flip it on the free body diagram. Taking the sum of vertical forces gives that FBG is 17.5 kilonewtons in tension. Taking the sum of the horizontal forces gives that FBC 13.1 kilonewtons in compression, so we must flip it on the free body diagram. Now, looking at joint D, we'll flip the force FDE, as we previously determined it was in compression. Then we'll apply the same process as joint B. This results in the following forces, making sure to flip those in compression. The same process is applied at joint C, making sure to flip forces FCB and FCD since they are in compression. Taking the sum of vertical forces shows that forces FCG and FCF are equal but opposite. So, when taking the sum of horizontal forces, we can make the following simplification, which helps solve for the value of FCG. This is equal to 3.12 kilonewtons in tension. Knowing FCF is equal but opposite, this means it must be in compression. And there you have it, Quick Statics Answers.